I want to give you guys a quick Tintri Primer. And to understand Tintri is to understand that we manage at the VM level. We were founded by Dr. Kieran Hardy, who was employee 25 at VMware. He was the VP of engineering that oversaw the teams that brought ESX and GSX to market. And so he saw where the industry was going from a virtualization perspective, but also saw that there was a huge gap in the way you could manage VMs from a storage perspective. And so when he founded Tintri, he founded it with the premise that you should not manage at a LUN and volume level, but you should truly be able to manage at the VM level throughout the whole entire stack. And to be able to do that, you have to have VM level quality of service. And that's what we do. We manage at that VM level and performance isolate each VM that's on the Tintri appliance. And because of that, obviously you're not going and carving LUNs to try to performance isolate VMs. And that gives us the capability to give ultra dense solutions. Within 4U of space, you get 100 terabytes of capacity to be able to utilize. And since we focus at the VM level, we also want you to be able to manage at the VM level. And so through our automation, we've exposed REST-based APIs and a PowerShell toolkit so you can manage all of the VMs in that way. And to that point, actually, Nick Collier at Ahead has utilized those to build VCO workflows to really automate the capabilities. And I'll talk through some of that in my demo. And the final piece is multi-hypervisor. You don't have to have a specific hypervisor to get these capabilities. That's one of the keys. Traditional storage players are asking the hypervisor vendors to come up with a solution to ultimately mask a problem that they don't understand at the VM level. And with Tintri, we're managing at that VM level across the board. And you guys will be able to see just that as I go through this. And so when we talk about manageability, it's having that transparency of the whole entire VM, how it's running, and ultimately what's going on from an IOPS, a throughput, and a latency perspective, and with historical graphs. And it comes down to being able to pinpoint what was going on in the environment and then be able to troubleshoot from there when you're looking back in time, when you're looking back at what was happening with applications. Is there a certain trend? We've exposed many different issues and environments just because of the deep analytical benefits you get because of Tintri's capability to understand at that VM level. And then looking at what we've developed lately is SyncVM. And there's two capabilities with SyncVM. The first is being able to time travel to any point in time within a VM snapshot tree. So, if you guys read the keynote today and you actually heard about DevOps capabilities, imagine being able to quickly move between versions and then also be able to very quickly move back and forth. That's just one of the capabilities that we have with SyncVM. And the second one is truly shortening application development cycles. I'm sure all of us have cloned VMs just to be able to use another instance of that VM. But that's very wasteful and it's not very efficient because you have to go back and reconfigure that VM every time you want to make another copy of it. And resynchronizing that data into those VMs also becomes a true pain. With this technology, you can select the specific vDisks that you want to synchronize that data into the children VMs. And it comes at a net zero cost because of the way that we do our clone dedupe technology. And so the first part of this is being able to see back in time, back at your applications, how they were running. This is the main dashboard. I'm not going to drill too much into that, but being able to go back in time, imagine you had an application owner or you are an application owner and you go and say, what was going on at this point in time with the storage? Well, with traditional storage, they're not able to see at the VM level. And so all they can show you are IOPS. How many IOPS are being written, how many IOPS are being read per LUN. You don't know exactly what VM was driving what on there. It's a guessing game at that point. Here, we can go back to any point in time, click, and see specifically what VM was driving those IOPS, and then along with that, see the other top contributors in the environment. This makes it very easy to understand what was going on in the environment from the storage performance perspective. But what about the whole rest of the environment? When you have to troubleshoot inside of an environment, it's not just the storage. it's your host, it's your network, and then it's also your storage. And being able to see through all of those layers where the latency is at and expose that is what Tintri is able to do for you. And you can see here that just by clicking on this, I can see the latency for all of the top VMs in here and also see the VM that had the most latency in the environment. But that's a macro view. Being able to get down to a micro view of a per VM is the next key in really exposing the application's performance and understanding that. And so, as I sort this, you can see that I've got the top IOPS inside the environment in terms of per VM, but it really comes down to understanding even at the latency level per VM. So driving into this, I'm now able to show you guys, and we'll wait for this to pull up. You'll be able to see that at the VM level, we can show the whole entire latency per VM. And so here, we can see that the latency for the host is obviously much higher than the rest of the stack. And so rather than being confused about where you're having performance issues from a VM, any kind of application slowdown, you're able to pinpoint very quickly in there. And you're also seeing another interesting color here. We've introduced the capability to throttle VMs, to actually throttle VMs from an IOPS perspective. So at a per VM level, you're able to guarantee or limit the amount of IOPS that each individual VM gets. So not only is our file system automatically doing this for you, we give you the capability to granularly adjust. So over time, as you see how your applications are running, you can then adjust those priorities on the system. And so this is at the VMstore view. We also give the capability from a global view, all of your VM stores, your whole entire environment, the ability to go back in time and see exactly how the full environment was running. And you can choose any point in time back up to 30 days. And say we want to go back to March 25th and we wanted to select a specific time, maybe something was happening at 8:30 p.m. Here we can see exactly a snapshot of the environment and then go and dig into the VMs. So being able to go back, look at each one of your applications, see how they're running across all facets of the infrastructure becomes another powerful tool in troubleshooting. So that's looking back. Looking forward of how you can enable your applications and move within snapshots. I've got an example here of Tintri's sync VM at that refresh disk level. And I wanted to use a real world application, so I used Sugar CRM. I've got data in here, and this is a live system, and this is the production VM, where we also have dev VMs. So taking production data and actually being able to synchronize just the data, not reconfigure the operating system, is ultimately what I'm going to do here. But you also have to think about how often can you do this? How often can the data be refreshed? Well, in this example, I want you guys to be able to see that we can take data as it's being written into the system from an ad hoc perspective and be able to synchronize that data down to those VMs. And you're not limited to just 2 VMs, it's as many as you want. I've ultimately utilized 2 just for simplicity's sake, but I'll add in Tony Bontempo here. He's the account manager for Tintri, and so if you like what you're seeing, give him a call. But this right here just represents how you can easily go and take data as it's coming into the system and synchronize it. And so what I'm doing here is I just want you guys to see I'm refreshing. There's no new data in this. We can see Tony's information up here at the top. And I'm going to utilize a script here to kick this off. But you can utilize VCO workflows. You can utilize our UI itself to do this. And I'll show you how to use our UI too. And so here, I'm authenticating against a Tintri VMstore, kicking this job off. It's done a fresh snapshot of the VM and is now synchronizing the data in. And so in the Tintri VMstore, you can see that we're already tracking this. Each one of the VMs now has this kicking off on there. And I want to bring up vCenter so you can also see what that looks like. Well, while I'm waiting on that, I want to show you the disk layout from a development VM. So you can see here, Dev 1 has 4 different disks. It's got SCSI00, which is the operating system. We don't want to wipe that out. And that means any customized applications can be retained on that VM. Any of the personalization that those developers now own is retained on that VM, but only the data, so that's disks 0, 1, 2, and 3, are actually being updated. And so that's your database, your log files, and your tempDB. Those are the only disks that we're actually updating at this point. And so looking back here, we can see that both of these disks are completed, 100%, and the UI is completely tracking all of this. So let me bring back up vCenter so you can also see what it looks like. Well, Murphy's Law. Ultimately in the UI, I want to be able to show you guys where the VMs are at from a configuration standpoint. And while I'm doing this, I'm going to go back into also the snapshots to show you just how we react to snapshots. Because one of the concerns is, if you guys want to go and do this, what's going to happen to that data? What if the developer wasn't ready for you to go and actually wipe it out? Well, we take safety snapshots for all of these actions in there. So when you were to actually kick off this process, we do a safety snapshot of that VM so you could roll back if that developer called you back and said, hey, I didn't want to actually go back to this, have my data refreshed. And right here is the fresh data snapshot that I took when we're actually injecting that data into those two children VMs. So at this point, both of these VMs should be updated. I'm going to actually hit log out because I need to clear some cache on these. And while this is logging out, I'm going to show you what it would look like in the Tintri UI to do this manually. So on the two dev VMs, you can select the two VMs and choose to refresh the virtual disks. At this point, you can select the actual VM you want to synchronize from. So it doesn't have to be a specific VM that you're looking to synchronize from that matches specifically with that dev environment. In this example, obviously I've used that, but you select whatever snapshot you want and you match up the disks the way that you need them to match up. So it's not a one-to-one mapping. You actually choose the disks and the specific data then gets injected into those VMs. So this would be the manual way of kicking it off versus the scripted way of kicking it off. But when I log into these two, you'll be able to see that both of them ultimately have all of that production data. So within just a couple minutes of what I was just talking about, you're able to see that we took all of that data and moved it into two additional VMs. Just imagine the capabilities of this. I've talked to other customers. It takes them 70 plus hours to do these kinds of data refreshes with thousands of lines of scripts. And other vendors may need you to mount REMs and do other goofy things to try to operate at this level because they're not managing at the VM level. And so as we take this further, you can think about, well, what if I want to roll that back? What if I want to take the whole entire environment back? How quickly can I do that? Well, I've also written a script for that, obviously. And so here, I'm kicking off the revert back script. And one of the keys here is that you can choose what VMs you want to revert back because it's going to reference the specific snapshots you want to go back to. So I'm taking the production VM back because I don't want to leave that data in that VM. And I'm also going to take the two children VMs back. And so now at this point, we shut down those VMs, we revert back the snapshot, and bring them back up. Consider this. You don't have to take a snapshot, register that VM into your environment, and then bring it back up because then you lose all of the performance metrics, all of the things that made that VM unique at that time get lost every time you have to clone a VM to actually bring it back to a certain point in time. With Tintri, all we're doing is replacing the vDisks in there. It's all a pointer-based file system, so it's very quick and efficient. And to that point of us having a pointer-based file system, you can see here that from a provision standpoint, this is how big the disks would be provisioned in that VM. But from a use standpoint, we're only using 0.01 gigabytes of space for those disks. Yet they're referencing all of that production data. So each one of those VMs that you build out ultimately costs you nothing in terms of storage to have those extra copies of data in there. And so at this point, as we're letting this roll back, I'll bring the script back up. I usually like to have vCenter to be able to see what was going on there, but I don't right now. And we can see that it's been going through and rolling back snapshots, deleting certain snapshots. A very quick and efficient mechanism to move between different snapshots in your environment. That is our capability to do application time travel. Yes? Thank you. So Tintri scales per appliance. I showed you guys Tintri Global Center earlier, and that's a centralized console. Each one of the Tintri appliances delivers up to 100 terabytes of usable space in a 4U rack unit. And so if you guys just imagine how dense that can get, and each one of those data stores, the reason why we can pull off delivering such a gigantic data store, and that's where you put all of your VMs, database, application, VDI, is because of that per VM QoS, truly performance isolating the VMs and even down to the vDisks. So, thank you. And you gave me enough time to be able to log back in and show you guys. I'll just refresh on this. And so as this connects back in, you guys will be able to see that, ultimately we've reverted back. So we moved to a certain point in time for that data, and then we're able to very quickly move back to the previous time. So hopefully you guys see how this can really enable some DevOps types of capabilities in your environment and take advantage of these unique features.